Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at Network Time Protocol, also known as NTP. We'll be discussing time and calendar services, NTP Operation, and then finally we're going to configure and verify NTP. This episode is part of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. The software clock on a router or switch starts when you boot that system up. That system clock, software clock, is the primary source of time for the system. Now, it's important to synchronize the time across all your devices on the network because that'll allow you to see how events are happening. If your times aren't synchronized, if everybody doesn't have the same time right at the same millisecond, things could happen across your network and you can't figure out what the order was from that. And so when it's not synchronized between devices, it's going to be impossible to determine the order of events and what caused the event. So you're troubleshooting. Now, typically the date and time settings on a router or switch can be set one of two ways. We can do it the manual way. Here on R1 from privilege exec mode, we can say clock set. Then we specify the time in military time, 24 hours, and then we put in the date. There's a couple formats for the date you can put in there. The question mark will list those out. And here the format we chose was November 15th, 2019. You go ahead, hit enter, and then you'll get a system update message saying we did a clock update. The system clock has been updated from what it was when we turned it on to what we want it set to now. So we changed, this was the original time here, and then we changed it to what we typed in right here. And so we were able to do that. Now, the second method to set your clock is using Network Time Protocol. As your network grows, it becomes difficult to ensure that all of your networking devices are operating with a synchronized time when you're doing it manually. You have to go to each device, you have to set those devices. Now, you don't have to go to each one. You could SSH into those devices and set it, but you're probably going to be off by some milliseconds. And sometimes activity happening in milliseconds on your network. Plus, you have to go to each one and do this. Now, a better solution here would be to use the Network Time Protocol, or typically known as NTP. Now, what this protocol does, it allows routers on the network to synchronize their time settings with an NTP server. So you set up one NTP server on your network, then all the devices will set their time based off of that NTP server. Now, an NTP can be set up to synchronize to a private master clock, or it can be set up to synchronize to a publicly available NTP server. NTP works in a hierarchical structure of time sources. Each level in this hierarchical system is called a stratum. The stratum level is defined as the number of hops from the authoritative source. The stratum 0 here, this is the authoritative source. So authoritative source. This is something like the atomic clocks that are in the world. There's a handful of them. This is the time source in the world. The Stratum 0 servers are high precision timekeeping devices. They are assumed to be accurate and with very little or no delay associated with them. Stratum 1 devices, so they're one hop from these authoritative servers, they're directly connected to these time servers. So there is a direct connection here from the authoritative time servers to Stratum 1 servers. They act as primary network time standards. Now, to be a Stratum 1 server here, you have to go through an application process. You have to prove you have the hardware, the bandwidth. You have to dedicate the resources to be a Stratum 1. So there are several of them. I guess I shouldn't say several. There's about 1,000 of them out there, give or take. and only select people get to directly connect to those stratums. And the only way you'd be a stratum 1 is if you're a really big company with the need to connect directly to one of those atomic clocks. A lot of people here are stratum 2, and so we are 2 hops. We have to go from where we're at to a stratum 1 and then that. What happens is this stratum 1 synchronizes its time clock, and then stratum 2 servers synchronize from a stratum 1 server. Stratum 2 servers here are connected to stratum 1 servers through network connections, the internet. Stratum 2 devices such as NTP clients synchronize their time using NTP packets from the stratum 1 device. So they have a NTP protocol that communicates back and forth. Stratum 2 devices also serve as NTP servers for stratum 3 devices. And so it starts growing like a tree, or I guess in this example, it would be a root system, how it gets, the lower you get, the more roots there are. One of the other things about the stratum is time servers on the same stratum, they can synchronize. Right here we have 2 time servers. They're on stratum 2. They can synchronize back and forth. And if you look at this, we have a handful of these authoritative servers in the world. Then we come out to about 1,000 of these stratum 1 servers. And so we go from a handful to 1,000. And then stratum 2 servers, there's a lot of those. And a lot of times you see these sort of at your company level. It's either stratum 2 or stratum 3. You can have up to, there are 16 levels of the stratum, 0 to 15. So it goes all the way down to 15. And if you're at stratum 16, so stratum 16 is possible, that means you have no time synchronization at all. I hope you're enjoying this episode on NTP. If you have the time, please leave a comment and let me know what you think about NTP. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. In a small company. Now, when I say small, I'm thinking 1,000 devices, give or take. You're probably going to want to set up your own internal NTP server, your network time protocol server. A lot of times you're probably only going to set up one, but this one internal server, you should have it connecting into about 5 different other NTP servers. Now, the recommendation is you connect into about 5 diverse different servers, and they should be a stratum 1 you're connecting into or a stratum 2. Don't go any lower than that because you want to be fairly close to that authoritative cert or that authoritative source. Now, the diverse stratums, you can connect into different layer 1, layer 2 places. You can look into connecting into the GPS system. That would be one. CDMA, you can tie into that system to get your time off of it. You can get into government servers, radio wireless. Also, some universities run their own. And so tying into different ones. To do that, you tie your server into that. Now, if you're tying into 1s and 2s, this will make your server a stratum 3. And in all honesty, a stratum 3 is a pretty good server to be tied into. You're fairly close to that authoritative source. Then you can have all the other devices in your company. Now, not just the networking devices, not just your routers and switches, but you can have all of your devices. Almost every device that you can connect into the network that has some configuration, you can set up that NTP server. And then you can reference your time server. And so you have all your devices. Time clocks are a great thing to do that because everybody has to punch in and out. And you don't want one time clock to be earlier than the other. So you want to synchronize all that up. And of course, then you want your digital clocks to be synced with the time clock. So as they're watching the time throughout the day, it says 3 o'clock, time to punch out. They walk over to the time clock, it says 3 o'clock there. And so syncing this all up, or syncing up your computer. At the end of the day, your computer says 3 o'clock, the time clock says 3 o'clock. And so having an NTP server is a really good way to go. In a larger company, instead of having one NTP servers, you're going to set up anywhere from 1 to 5. And the recommendation here is to have kind of a pool of 5 of your own internal servers. And once again, we're talking a large company. We're talking tens of thousands of devices on there. Each one of your internal servers, you're going to have these 5 diverse Stratum 1 or 2 sources so they can sync with. That will then create your pool of NTP servers, which then you have your devices, they can connect into it. That pool gives you redundancy, failover if you have any problems. To configure and verify NTP on your networking devices, routers and switches, first thing we can do here is say show clock detail. Show clock detail will give you the time and the date that is configured on your device. We can then go in, we can set it up. So we go into global configuration mode, and it's a fairly simple command. You say NTP and then the word server, because you want to go to the server, and then the IP address of that server. And there's a lot of servers out there. When you're done with that, you can go back into privilege exec mode, and you can type in show clock detail. When you do show clock detail, you can see that the time has been adjusted correctly. Now, where did it come from? It is time source is NTP. So it's saying it pulled it from an NTP server. Up here when we did it first time, it said time source is user configuration. You manually set that. Now, you may not have. You may have just turned on the device and the system clock started, but it won't say NTP. Once we set up our NTP like we did here in the center, we have the right time, and we'll say the time source is from the NTP. To look and see where you're actually connected into, we can use the show NTP association. So show us where we are associated, and it'll list out. You can have multiple NTP servers in here. Right here, we only have one configured. This was the one we just did on the previous slide, 209.165.200.225. The reference clock is saying, where did this server get it from? They got it from the GPS network. Pulling it off the GPS network, great place to do it. What is this clock? This clock, the 209.165.200.225, is actually a Stratum 1. It is right there, one step down from those atomic clocks. So we have information about the device we are connecting into. We have some other statistics here when you get into the actual details of how NTP works. It was when did we last see it? Our poll interval, how many times we have, what was the delay from our NTP server, what's the offset. So this is all some information. When you dig into the details of NTP, you can go in and configure it a lot more. But what I wanted to show you here is once you see your associations, we can also do show NTP status. When you do show NTP status, you can see that your clock is synchronized, and that we are R1, where we ran the command, we're Stratum 2. You're just 2 steps from that authoritative. And where did we get our reference from? Our reference came from 209.165.200.265. That was what we set up. It was one of our NTP servers. It was my pleasure to provide you with this wonderful episode on NTP. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my contacts and information are on my website, KevTechify.com. There, you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.